I wanted to give you one of these, which is a little more complicated, and indeed it is. And I don't know what kind of answer we're going to get because I just made this up. Curly can mow the yard in 2.5 hours. Mo can mow it in 3 1/4 hours. If Mo mows, probably not the best choice of names here. If Mo mows for 1 hour with Curly, how long will it take Curly to finish mowing? All right, so my little tribute to the Three Stooges, who I think were a pretty stupid team, but oh well, they amused a lot of people, including me when I was a kid. All right, so now this is written in hours, and they're kind of inconvenient numbers because they're fractions, and so I think I'm inclined to change these to minutes. So let's write out the rate at which each one can mow. Curly, Curly. I think he was the bald guy. Curly does 1 yard per, now how many minutes would that be? Well, 60 minutes an hour times 2.5 would be 150 minutes. 1 yard per 150 minutes. And Mo does 1 yard per, what, 3 hours is 180 plus a quarter hour, 195 minutes. 1 yard and 195 minutes. Okay. So, I don't know. It avoids maybe some complications. I'm not sure that's going to be the friendliest way to do it because these are kind of big numbers. But we'll just see what happens. It'll work either way, whether you use minutes or hours, as long as you're consistent with what you're using. Now then, I want to know, well, how much did they get done in 1 hour? All right, so let's see. In 1 hour, 60 minutes. So in 60 minutes, Curly, I have a hard time writing that tonight. Curly mows, and if I multiply 60 minutes times the rate at which he mows, 1 yard per 150 minutes, then I get a fraction. All right, let's see, the 6 on the zeros cancel. I can divide 10 into both. And then 6 and 15, I can divide both by 3. So I get 2/5. He does 2/5 of a yard. 2/5 of a yard. All right, now how about Mo? Mo's probably going to be a pretty bad fraction. Mo mows. Again, it's going to be 60 minutes, and this time his rate of mowing speed is 1 yard per, what was it, 195 minutes. Okay, so let's see if we can reduce that. I can divide them both by 3. Actually, by 15. We can divide both by 15. So if I divide 15 into 60, I get 4. And 15 into 195 is 13. 4/13 of a yard. Okay, now I promised you this one's going to be a little more complicated, but really the only thing that's probably the most complicated thing is just the fact that we get some, less friendly fractions here. Not too friendly fractions. But in 60 minutes, we know how much of the yard they have mowed together. It's 2/5 plus 4/13. So they have, I'm going to have to make room here. And I'll write it out. And I don't expect you to write all these words out, but I'm writing out as notes. And because this reflects how I'm thinking through it. So in 60 minutes, they mowed. All right, so it'd be 2/5 plus 4/13. And I need a common denominator here. It's going to be 5 times 13 is 65. So I have 26 over 65 plus 20 over 65. This is 46 over 65 yards. All right. Now that in English that sounds awkward, but that's the fraction that they've done. 46 out of 65 is the fraction of a yard that both had mowed together. Now what does Curly have to do? Curly has to mow the remaining part. How much yard is left? So remember how fast he mows. We're going to need that. And make some room here. Alright, so Curly has 1 minus 46 over 65, which is 65 over 65 minus 46 over 65, which is what? 65 minus 46 is 19 out of 65 yard to mow. Alright, so that's what's left over. He has that fraction left to mow, 19 over 65. Okay, now how we're going to finish this, we don't know how long did it take him to complete the job. And we have his mowing speed is 1 yard per 150 minutes. So how are we going to put the units together here? All right, well, here I want to somehow mix this together so I end up with minutes. And I want to end with minutes, which means I need to cancel off the word yard. And minutes has to be a numerator. His speed written here has minutes as a denominator. So watch what happens here. I'm going to invert this. He does 150 minutes per yard. It's a different kind of rate. 1 yard. And so he also mows at a rate of 150 minutes per yard. And he needs to mow 19 over 65 yards. Now, yard is a numerator. So when I multiply these together, the units work in our favor. And my handwriting is not working in our favor. Let me make this a little more legible here. That's supposed to read 65. There we go. So the word yard cancels. I'm left with minutes. That's what I wanted. I wanted the minutes it took him. So 1/650 times 19 over 65. And something tells me that's not going to make for a very easy fraction. Let's just go ahead and estimate it. So 150 times 19 and then divided by 65 is 43.8 minutes. So it's about 43.8 minutes. Oh, you could probably call it 44 minutes. So, in fact, at that scale, I think I would probably just call it 44. This is not meant to be terribly precise. So, our answer, it takes, or Curly needs about 44 minutes to finish. Okay, about 44 minutes. Well, there you go. That's, again, let the units do the work for you. And here it's there's really no algebra. The way I did it was just a matter of organizing the units so that they canceled properly in order to get through this. We did have to do a little bit of logic to it and think through it, but I hope that was clear to you.